Don't throw it back. If you find a rock that is bright green or deep royal blue, and it feels twice as heavy as it should, do not throw it back. In 2019, Heritage Auctions sold a single branching native copper crystal from Michigan's Keweenaw Peninsula for $27,500, and the entire specimen fit in one hand. That same geological formation sits on BLM public land in 3 states right now. By the end of this, you will know how to run a streak test using a $2 unglazed ceramic plate that reveals each mineral's identity on contact, and a specific gravity displacement test using a $15 AWS digital pocket scale, and a cup of water that proves native copper instantly because nothing else at a density of 8.9 feels that impossibly heavy for its size. 5 copper minerals, exposed in under 30 seconds with 2 cheap tools. But the vinegar acid test is the one that will shock you, because it separates the entire copper carbonate group from every silicate lookalike with a single drop from a bottle that costs you nothing. Nobody was paying attention to copper minerals 20 years ago. Gold got the headlines. Diamonds got the documentaries. Copper was industrial scrap that nobody collected. The gem dealers in Antwerp's diamond district knew better. They had been quietly buying specimen-grade copper minerals since the early 2000s, tracking Bisbee Azurite the way the art world tracks Rembrandt provenance. Over the last 2 decades, individual copper crystals have fetched prices at auction that rival cut gemstones. And the wild part is that these rocks announce themselves. Bright greens that look airbrushed, royal blues that look like enamel paint, metallic reds that look like frozen wire sculptures growing out of basalt. I have watched people walk right past them on BLM land in Arizona because they assumed the color was artificial. You are not going to make that mistake anymore. I want to start with the one I find most often in the field: malachite. Pick up a fist-sized chunk of banded bright green malachite with a bubbly botryoidal surface, and you are holding copper carbonate hydroxide that formed in the oxidized zone above a copper ore body. Rainwater, oxygen, and copper-rich fluids built those concentric green bands over thousands of years. Specific gravity of 3.9 means they feel noticeably heavier than ordinary green stones, like serpentine. Mohs hardness is 3.5 to 4. The field conformation takes 10 seconds. Drag it across your $2 ceramic streak plate and look for a green powder line. Then drop white vinegar on the surface. If it fizzes, you are looking at a carbonate, and a green carbonate with botryoidal habit is malachite until proven otherwise. That fizz instantly eliminates Chrysocolla, serpentine, and every other green mineral that does not contain carbonate. For value, banding determines everything. Plain botryoidal malachite sells for $10 to $30 per pound. High contrast specimen grade material runs $40 to $100 per pound. The world benchmark comes from Kolwezi in the Democratic Republic of Congo. Miners there pull out fibrous velvet malachite that sells for $200 to $1,000 per specimen. If you want more field guides like this, exact coordinates, and the tools I carry in the dirt every week, subscribe now. I put these out regularly. Back to the rocks. The next one stops people cold. Azurite. I have seen experienced rockhounds pick up an azurite cluster and ask me if it was dyed, because the blue is too intense to look natural. Azurite is also a copper carbonate hydroxide, but a slightly different molecular ratio produces one of the most intense natural blues on Earth. It forms in the same oxidation zone as malachite, which is why you find them intergrown in a single specimen called azurmalachite. But azurite is less stable at the surface. Given enough geological time and water, azurite slowly converts to malachite. That instability is precisely why pristine crystal clusters are rare, and why collectors pay a premium. The streak plate gives you light blue powder. Same vinegar test works. It fizzes. crystal specimens sell for $30 to $500 per piece. And then there is Bisbee, Arizona. The Copper Queen mine produced what collectors call Bisbee Blue, Azurite so perfectly crystallized that mineral dealers in Antwerp and Geneva track individual specimens the way auction houses track old masters. A single Bisbee Azurite cluster sold for $785,000 at heritage auctions in 2014. But the ground was keeping a much darker secret than its jewel blue crystal suggested. On July 12, 1917, Cochise County Sheriff Harry Wheeler deputized 2,000 men who went through Bisbee before dawn with rifles. They rounded up 1,186 striking miners, marched them to a ballpark, and loaded them into 23 cattle cars. The train traveled 200 miles through the desert to Hermanas, New Mexico. 16 hours. No food, no water. Abandoned in the desert and warned never to return. A presidential commission declared the deportation wholly illegal. No individual was ever convicted. The mine kept producing its deep blue azurite for decades afterward. That is not a misprint, by the way. 16 hours in desert heat in a cattle car, a presidential finding of clear illegality, and 0 convictions. The chemistry shifts completely with the next mineral. Chrysocolla is not a carbonate. It is a hydrous copper silicate, closer in structure to clay minerals. Its color runs from bright teal to washed sky blue, commonly forming with a druzy quartz coating that gives a sparkly frosted texture over the blue-green base. Mohs hardness 2 to 4. Specific gravity only 2.0 to 2.4. Light for a copper mineral. The separation test takes 3 seconds. Pour white vinegar on it. Nothing happens. No fizz. That single test instantly separates Chrysocolla from Malachite and Azurite. Common rough sells for $5 to $20 per pound. But when Chrysocolla forms as a transparent variety called Silica, the numbers change completely. Silica from Arizona is worth $50 to $300 per carat when translucent. Everything so far has been a compound. Native copper breaks that pattern entirely. It is the element itself, crystallizing directly as metal in the rock. I have held native copper specimens from the Keweenaw Peninsula that made my arm tired. The metal grew inside gas pockets of ancient basalt flows, pushed up by hydrothermal fluids over millions of years. What came out were dendritic, branching formations of red-orange metallic copper that look like frozen lightning bolts. Specific gravity is 8.9. Hold a piece the size of your palm, and your first thought will be that someone gave you a chunk of lead. A $15 AWS digital pocket scale and a cup of water confirm it through displacement. A $5 to $10 neodymium magnet shows a faint but detectable attraction that green and blue lookalikes will not produce. The Ontonagon boulder, 3,708 pounds of solid native copper, sits in the Smithsonian today. Heritage Auctions sold Michigan native copper crystal groups in 2019 for $22,500 to $27,500 per specimen. Smaller branching pieces sell for $50,000 to $5,000, depending on formation and size. The last mineral might be the most dramatic looking of all. Cuprite crystals are dark red to nearly black, and when light catches the crystal faces, it throws back a flash that geologists call adamantine luster. That is the same term used for diamond. And no, I am not being poetic. The refractive index of cuprite is high enough that small crystals genuinely sparkle like dark red gems under direct light. The crystal habit is octahedral. 8 perfect triangular faces, forming 2 pyramids pressed base to base. Cuprite is 88.8% copper by weight. Specific gravity of 6.1. Pick up a small cuprite octahedron, and your instinct will tell you it is a piece of steel. Streak on your ceramic plate is brick red. Vinegar produces no fizz, because cuprite is an oxide, not a carbonate. Transparent cuprite crystals from the Onganja mine in Namibia have sold for $1,000 to $2,250 per crystal. Cuprite forms specifically in the oxidized zone directly above native copper deposits. Finding quality cuprite in the field is often a geological signpost that native copper is somewhere below you. Think back to where this started. I described somebody picking up a fist-sized chunk of banded bright green malachite and calling it painted. Somebody holding a royal blue azurite crystal and asking if it was dyed. Somebody feeling the impossible weight of a dendritic native copper specimen and insisting it could not be natural. All 5 minerals on this list share one quality that makes them invisible to people who do not know what they are looking at. They do not look like rocks. They are too vivid, too heavy, too geometrically perfect, too red. That is exactly why they are worth learning to identify. On BLM land in Arizona or Nevada, on open crown land in British Columbia or Ontario, on a Western Australian station with a $25.50 lifetime miner's right in your pocket, any of these 5 minerals could be sitting on the surface right now, waiting for someone who knows what a $2 streak plate and a bottle of white vinegar from the gas station can tell them. The tools are cheap. The knowledge is the edge.